Okay, now the row-reduced echelon form on the calculator, which again, I'm assuming most of you will do this. I'll be using the 84, even though it says 83 there. 84, 83 is a very similar. Inspire should work the same way. Again, if you have a Casio or something else, you'll have to figure out, but all of those should be capable of doing matrix reduction. All right, so where it's located is a little buried, and the process is a little involved. All right, but it is under the math key. So you know on your calculator you have a key that says math, and then you actually have to scroll. So what you have to do is it's a sub of the math key. So the matrix is you have to hit second. The thing under the math key. Under the math key is there's the inverse key is what you have to get. And I'll show you. I'll pop my calculator here in a second. All right, so I'm actually going to work through the first example to show you this. All right, so the first thing is make sure it's in standard form. Now, you don't have to get rid of fractions since we're going to plug it in the calculator. So in standard form, you can leave it 3/2, 5/4, 0, 0.2, 0.3, 0.4. Now, what the calculator does is it goes row by column when you plug it in, and so this is 2 rows and 3 columns, so 2 by 3. All right, so where to find that on the calculator? All right, so here's my 84, and so what you have to do is under the math key, if you look under my math key there's the X with the -1 button. Above that in blue letters is MATRIX, matrix, and so I have to hit seconds, that button, and it'll take me to the matrix menu. Alright, which again, my calculator's program, it's got nothing in there. If yours has stuff in there, it's fine. What you want to do is, I usually just pick the first one, so A, and then I'm going to go over here to edit. Alright, so I'm going to edit first thing. So edit means, because I'm going to plug my matrix in. And so I'm just going to edit matrix A. You can edit whatever matrix you want, so I'm going to edit matrix A. First thing I have to do is tell it the size. It's a 2 by 3. It's 2 rows by 3 columns. So first thing you have to type in is 2. And then 3. All right, and then it should give you enough. So it zeroes out. There's my 2 by 3. There should be 3 spots in each row. And then you just carefully type it in. All right, so 3/2, 5/4, 0, and then 0.2, 0.3, 0.4. Alright, once you've got those marked in there, quit, so hit second, quit. And then what you'll have to do is we actually have to go into matrix 3 times. We have to get edit, put our matrix in, we do calculations, row reduction, form, and then we have to pick our matrix. And so we actually have to go in 3 times. So go in there again, hit second, matrix. Alright, now I want to go over to math, so I'm going to select the math key. Alright, and then I have to find the rref. And it's actually off the page. I have to scroll down. And you want the double R, so B. rref, and then there's a parenthesis. So make sure you go down to B. So again, we're in matrix. You have to hit second, X to the -1 button. Go over to math, scroll down till you get to B, and you with the rref, hit enter. And it'll pop up on your head. Now, you're not ready to go yet, so you have to go back into matrix a 3rd time and select your matrix. So now I'm going to go back in. I'm going to hit second, that X to the -1 key, and pick my matrix A, because that's the one I plugged it into. Hit enter, and parentheses. And so at the top of your home screen, it should have rref, row reduced echelon form, my matrix A, right, which is the matrix I want. Hit enter, and it should do that for you. And there we go. There is the row reduced echelon form, which gives me down to 1x, 0y equals constant, 0x, 1y equals a constant. And so the answer when we do our row reduced echelon form comes out 1, 0, -2.5, 0, 1, 3. And then there's my answer. That's my x, that's my y equals my constant. And so the first row gives me x equals -2.5. The second row gives me y equals 3. And so my solution is the point -2.53. All right, and so there's the calculator work. So from here on out, I'm just going to pop it up on my own screen. But again, that's the process. You have to you have to plug it in and then get the answer. And so that was the one solution case. I'm going to do one of each cases. So one solution, and the next one's going to be either no solution or infinite in the mini. I can't remember. than the other case. So example 3. So again, first thing, there it's in standard form. If it's not, then you do have to move it around. So in your calculator, you're going to, again, 2 by 3. So, matrix A, call that matrix A or whatever matrix you want. 2, -5, -15 in row 1. 3, -3. 7.5, -7.5 in row 2. Do the rref, my matrix A. And then it should spit out if you've typed that in. So again, type it in carefully. Make sure you've got the right numbers across the top, across the bottom. Go to math, pick the rref double R, and pick your matrix A. Hit enter, and it should give you the following answer. It should give you 1, -2.5, 0, 0, 0, 1, which this is a special case. Remember, there's an invisible equal sign here. It's my x, my y equals my constant. And so this last equation, right, this is row 2, which represents an equation. That equation is telling me 0x plus 0y equals 1, which again, 0x, 0y is really just 0. 0 equals 1, well, that's false, right? 0 does not equal 1 whenever we get a false statement. So whenever that happens, and it's always going to happen that way because of how the Gauss-Jordan method works, is they always reduce it to the very first number in each row is a 1. They divide it out the way the program works. And so this case is always going to come out on the calculator with this row in it. All right, it's going to have a row with zeros for the x and y's and a 1 for the constant. It's always going to be a 1 for the constant because of how the program works. And so whenever you get this 0 equals 1 case, that's always false. And so this is the no solution outcome. The lines are parallel, which means the next one's going to be my infinitely many case. All right, and example 4. So again, plug it into the calculator. All right, so in the calculator, you're going to plug in 2, -1, 4 across the top, -4, 2, -8. That's going to be my matrix A. Then I'm going to row reduce echelon my matrix A. And then I'm going to get, when I do that, so again, type it in carefully. Make sure you go to matrix math, scroll down to the rref, matrix A, and when you type it in, you should get out across the top 1, -0.5, 2, and then you'll notice the last row is all zeros, right? This is the elimination when we did the no solution case. We got 0 equals a constant, and when we got the infinitely many case, everything zeroed out. Well, that's this process. We tried to eliminate the x value, but when we tried to eliminate the x value, all the parts got eliminated. And so we were left with the 0 equals 0. And so this is the infinitely many case. Right? The two lines are really the same solution. And so I have to write my equation. All right? So I have to write my equation to give all, which are infinitely many, solutions. Now, due to the nature of the Gauss-Jordan method, remember when I did this using the matrix, not using the matrix, when I did this in 3.1, I showed you both methods. Due to the nature of how the Gauss-Jordan works, the Gauss-Jordan works where it will always get down to a 1x here. It's the way it works because of how the program works. So it'll always be 1x, some y, some constant, and then everything in the bottom zeroes out. And so remember what that row 1 really means. That row 1 is these are my x, these are my y's, those are my constant. And so that row 1 represents an x minus 1/2 y equals 2. And so whenever the Gauss-Jordan method is working, it'll always simplify to 1x. It'll always divide, so you get a 1x here. And so the easiest route to go in this case is to put it in terms of y, to solve for x, because it's really easy to solve for x, and put it in terms of y. And so when we use this method, we're going to let y be the arbitrary variable. Because it's the easier one, because I can easily solve for x. I can solve for x in terms of y. And so again, I can solve for x, pretty easy. Right, this would be some equation with an x in it. And so what that usually means is I just have to move the y over to the other side, right? In order to solve for x, I've got to move that 1/2 y to the other side. And so x equals positive 1/2 y plus 2. Meaning I pick any y value I want. As long as I've picked a y value between negative infinity and positive infinity, I'll plug it into this equation and I'll have the x value that's paired with it. And so with the Gauss-Jordan method, it's always easier to let y be the arbitrary variable. Alright, so my solution is the point that represents all of the solution values, which they're infinitely many, where x has to be 1/2 times y plus 2. Y can be anything I want it to be. We call y as the arbitrary variable. Meaning I pick my y and I plug it in and I've got a solution. Right? Y can be anything. To pair it with the right x value, I have to plug it into this equation 1/2 y plus 2. Now, technically, you could put it in terms of x if you wanted to, but that's the harder way. With the Gauss-Jordan reduction, it's always going to simplify to 1x, and so it's always going to be easiest to put y as my arbitrary variable. And we'll practice this more in the next videos. I'm actually going to do a whole bunch of arbitrary cases in the next videos. Alright, so we're going to stop there. In the next set of notes, we're going to look at adding equations and adding a variable. So I'm going to look at a 3-equation case and a 3-variable and 3-equation case. And so that's what the next video is going to do.